Now, once we've learned to convert, now I'm going to ask you to be able to evaluate the value of a log. There are 5 kinds of evaluate problems, those that we want to do mental math, and those are the first 4 examples right here. And then there's the kind where you're just going to have to use a calculator. But I'm going to show you how to handle the mental math ones. So the most normal kind is when our base right here is smaller than the value. Because remember, you just need to think this doesn't have an equal sign, but we could certainly put an equal sign right here and put an X right there. And now you could convert it back to an exponential. And that would be the base stays the base and the other 2 switch places. So this is what you're thinking, okay? You can certainly write it down, especially when you are first starting to do this, but eventually, hopefully, the idea here is that this gets to be mental math, okay? So you don't actually do that part, but this is what you're going to be doing. Then we just simply have to say 2 raised to what power will give me 8. You should not have to use a calculator as long as you can rewrite these as the same base. What I mean by that is 8 is just 2 raised to some power. So again, this is mental math. You know that that 8 right there can be rewritten as 2 to the 3rd power. What we're doing right here is called same base, solving exponentials using the same base. We changed that 8 into a base 2 because now we can just see right here that this x has to be 3. So x is equal to 3. We just drop the bases and we set that equation equal to each other, and we know that 2 raised to the 3rd power will give me 8. So the answer that we actually put over here is log base 2 of 8 is 3. The value of a log problem is always going to be the exponent. Okay, so you could do any of the others, like, let's see, log base 7 of 49. Okay, you should be able to evaluate that one. That means 7 raised to what power will give me 49? Well, you can certainly do this change of base thing that we're doing over here. You could certainly rewrite that, but hopefully you can just remember that 7 raised to the 2nd power, the exponent is 2, 7 squared gives me 49. Okay, let's do another example. Let's do log base 3 of 27. Okay, so this is saying 3 raised to what power will give me 27. We know that 3 times 3 is 9, and then 9 times 3 gives me 27. So that's 3 raised to the 3rd power will give me 27. So again, mental math. This problem right here could also be done change of base. So I could say 7 raised to what power equals 49, and then rewritten the 49 as 7 squared. Then you drop the 7s and you just end up with x equals 2. Same thing with this one right here. 3 raised to what power will give me 27. Rewrite the 27 as 3 cubed, drop the 3's, and we figure out that x is equal to 3. Okay, so all of these problems, this is really what this part right here, this part right here is what you're doing mentally. Okay, that's showing your work, but you don't have to on these. Now this one, we're starting off with the base is bigger than the number. So that, and when I say there's no fractions in the problem. But what that means is, this means that my answer is, when this happens, when B is bigger than A and neither one of them are a fraction. When I say no fractions, I mean here or here. But actually what's going to happen is my answer is going to be a fraction, okay? So remember, this means 8 raised to what power is going to equal to 2. Do a change of base. I can change this 8. Whoops, forgot to change it. I can rewrite that 8. I know that 8 is 2 to the third power. Okay, and that's still being raised to the x, and that's equal to 2. Well, my exponent rules say that a power raised to a power, I just multiply those. Okay. And we know that this, now I've got the common bases. Okay, they each have a base 2. I know that this has an exponent of 1, so I drop the 2's and I just write 3x is equal to 1. Those are the exponents. And now solve for x. How do I solve for x? I divide both sides by 3. So what's happening right here is there's still that relationship between the 8 and the 2, okay, because 8 is still a 2 raised to the third power, but because I'm starting off with a big number and I'm ending up with a smaller number, that means I'm rooting it. Okay, this is a root problem, and so my answer is going to end up being a fraction. And that's always the case. Anytime B is bigger than A, you should end up with a fraction as an answer. Okay. Now, here we go back to another problem that's showing us that we have a base 2 and it's equal to a fraction. So technically 2 is bigger than the 1/8, but since it's a fraction, what that's telling me is I'm going to have a negative answer. So the clue here is that I started off with a whole number, I ended up with a fraction. That means that to look out for a negative exponent, because if you remember from our rules of exponents, x to the negative n is equal to 1 over n. So, oh, that's not right. X to the n. So what do we do when we have a negative exponent? We put it in the denominator. So that's kind of what's happening right here. So you can rewrite this. 2 raised to what power is going to equal 1/8. Okay. To make this be a common base, I'm going to rewrite that 1/8 as 2 to the x power is equal to 1 over 2 cubed. Okay, and then so I can have a common base, I'm going to say 2 to the x power is equal to 2 to the negative 3. I'm going to use this property right here to rewrite this. Now my bases are the same, a 2 and a 2, so I see that x is equal to negative 3. So as I said, when I see that I have a base right here, a base of 2, and then it goes to a fraction, or I have a base of anything and then it goes to a fraction, that means I'm expecting my answer to be negative. And then the last example where you can use mental math is where you have the bigger base right here and a fraction. That should tell you that I'm going to have a negative fraction as an answer. So we're going to do it the same way. We're going to rewrite it. 8 raised to what power will equal 1/2. Okay, I see a base 2 right here, so this becomes 2 to the negative 1, and this becomes 2 to the 3 raised to the x. And then what do you have when you have a power raised to a power? You multiply. Equals 2 to the negative 1. Bases are the same, drop the bases. 3x is equal to negative 1. Divide both sides by 3. X is equal to negative 1/3. So here, when I do have a base that's bigger than my value, but it is also bigger because it's a fraction, you should expect a negative fraction as an answer. So this came out to be negative 1/3. And then there's going to be those where you don't have a common base. You cannot change a 5 into base 2 at all. That's going to be a calculator, and you're literally going to type it in exactly like that on the calculator. So on your Inspires, your template key right here has a log template. So you select that one. It gives you a place to put your base, log base 2 of 5, and it gives you a decimal value. that should make sense to you, because we know that 2 raised to the second power is 4, so that's a little bit too small. 2 raised to the third power is 8, so it needs to be a power somewhere between 2 and 3, and 2.3 is between 2 and 3. So that's how you would evaluate it using a calculator.